Hello everyone, and in this video we're going to take a further look at our interactable objects. We're going to create a moving platform that when the player lands on it, he will move along with the platform as it's moving in multiple directions. So we're going to use what we learned from the lesson in Lerps with the navigation meshes and with the Lerp lesson earlier to apply it to a moving platform. So to get started, I'm going to make a new scene. So I'm going to go to File, New Scene, and I'm just going to save this scene, and I'm going to call this Scene Interactions. Alright, so now that we have that, I'm going to start off by creating a plane in the scene. So I'm going to go to Game Object, 3D Object, and Plane. And we'll create a plane in the scene. And I'll reset its position so it's in the center. And I'll scale this up. I'm also going to create a cube. And I'm going to resize this cube to basically be like a platform in our scene. And I'll put this out here. Make sure the Y is set to 0. And this is going to end up being our platform. So I'm going to rename this platform. And I'll move it here. Now I'm going to duplicate it and move another one right to the side of this one. And this is going to be platform moving. This will be the one that moves. So this one will make it so that it lerps back and forth to the main area here. Now this particular setup, we are going to use a lerp. There's a bunch of different ways you could make moving platforms. You could make them without using code, using animation, and my suggestion would be nesting the animation in an empty game object so that you could replace those platforms wherever you need to. Another way is to use the move towards function. So you could set up some positions either through code or through game objects that you scatter on the scene like gizmos, and then use the move towards function like we did with the enemy in the class lecture. We could also do a lerp and lerp between two positions like we did with the navigation meshes and with the lerp test that we did in an earlier video. So there's a whole bunch of different options that you could go through to create a moving platform. This is just one of them. And this is a pretty nice one because it's modular. You could prefab these objects and then be able to set up your platform moving in any direction that you would like to. Some issues with it is starting and stopping. Starting and stopping can be difficult because it is based off of time, and if you stop it, the time will continue, and the platform will kind of like teleport to a different area. So there's some issues here and there with this type of platform, but all in all, it's a pretty functional one. So we'll take a look at how this works. Now I'm going to need a couple of empty game objects. I'm going to create an empty, and I'm going to call this platform start. Or we'll call it start. Oh, if I could spell it, would be great. And I'm going to duplicate this one. And call this endpoint. Alright, so we got start point and end point, and we can position those into different areas. So I'm going to take endpoint and move it here, and I'm going to give it a label so that we can see it in our scene. If you don't see your labels, make sure you turn the gizmos button on here. And I'll grab the start point, give this a label, and I'll move it over to where I want the platform to start, which is over here. Alright, so we have a start and end point for this thing. We also have a platform. There's one last thing that we're going to need, and that's a trigger on top of this platform, so that when we jump and land onto this platform, what we're going to do is we're going to parent the player controller to it, so that it moves with the platform. So first thing we'll do is we'll create that trigger. I'm going to go to add component on the moving platform, so platform moving, and go down to physics and then add a box collider to this. I'll turn on the edit for this box collider, and I'll set it to trigger, and I'm just going to edit it so that it's a little bit bigger here, so that when our player controller enters it, he'll get parented to this, and I can shut this off. Alright, so I have this set up to be a trigger. The last thing we'll need is the player controller. So if I jump into my prefabs folder, I've got the player CC. I'll drag that onto the platform that I created that's static here. And a couple of things that we're going to need to do for this guy is I think he has a script on his main camera for raycasting. We're going to shut that off so it doesn't throw any errors. And the other thing we need to do is put all of these objects on the ground layer so that we can jump on and off them. So I'll go down to ground here, and all these objects will be part of the ground so we can jump up and down on them. So just to do a quick test, oops, I forgot that we still have our main camera in the scene. You could delete the main camera too, we don't need that guy. Alright, so if we hit play, and if we jump up and down, we should be able to jump up and down. Great. I'm keeping this jump kind of floaty because it'll make it a little bit easier to test. Alright, so I've got the start point and the end point here. Now we're ready to start scripting. So I'm going to jump to my scripts folder, and I'm going to create a new C# script. I'm going to call this moving platform lerp. And we'll open that up in Visual Studio. So where is moving platform lerp? The reason why I use lerp is that we're going to actually add all of the code into here. Now there's a couple of variables that we're going to need. The first two variables are going to be transform variables, and those are going to be for those start and end point gizmos that we created. So we'll say public transform, and this will be start point. And then we'll duplicate this line here, and I'll call this endpoint, because we're going to need one for each. Next thing we're going to need is a couple of variables to run the platform. The first one is going to be a public one, and this is going to be for speed. This doesn't really affect the speed. This actually affects its position in space. I don't know why I called it speed, but we'll call it speed. And then this will be equal to a default value of 1.0f. Alright, so we're going to have a couple more float values here, so I'm just going to duplicate those two lines here. Control D, Control D. And the next one is going to be distance. It's going to be the distance that this thing travels. And I don't know why I've got these semicolons here. And the next one's going to be start time. We're going to use this to basically keep track of how much time has passed while our platform is moving. And I'm going to get rid of the default value here. We're not going to need that. Alright, so we've got speed, we've got distance, we've got start time. I think that's all we're going to need at the moment. In the update function, we're going to change this to a fixed update. The reason for that is that we're using the character controller component, and when we parent the object just using the update function, it's going to fall off the platform. So we're going to want to move this thing using a fixed update. Alright, so the first thing we're going to do is we're going to set up some math that will alternate the platforms so that when it moves in a specific direction, it'll move in the opposite direction once it reaches the maximum distance or the maximum value that we're setting it to. And this is a function called math.pingpong. And what math.pingpong does, like I said, is like it alternates to a certain value and then it runs backward from a certain value. So we'll create a float here. And we'll call this dist moved. And dist moved is going to be the distance that we've moved. And this is going to be set equal to a math and dot ping pong. So we'll say ping pong. And ping pong, just like a ping pong ball, when it bounces up, it reaches a certain point depending on how much has been applied to it, and then it falls down, right? And then it just keeps bouncing up and down, up and down. And that's what these math values are going to do. So we're going to pass to this thing time.time. Time.time, and then we're going to subtract whatever the start time was. And then we're going to take distance, which we have up above, and divide that by speed. And that's going to give us a value. What happens is if you just try to pass the value directly to the lerp function and it runs continuously, eventually the numbers get smaller and smaller and smaller, and it doesn't run at the same speed or move the same distance. So what you have to do is you kind of have to calculate these points so that they continuously have the consistent distance from one another. All right, so the next thing we're going to do is we're going to do a transform dot position. And we're going to set that equal to our lerp. So we're going to use a vector3 dot lerp, and we're going to pass to this the values of the start platform and the end platform. So we'll do not the start platform, but the start position and the end position. So we'll do the start point dot position, and then end point dot position. And then the last thing we'll do is we'll add the distance the distance moved divided by the distance. So we'll take the dist moved and then divide that by distance. There we go. So this should pretty much take care of the movement of the platform. So let's save this and then jump back into the editor here. And we'll select our moving platform. Give my script a second to compile. And let's see, where is my platform movement script? I know you're here, I just saw you. Alright, moving platform lerp, there it is. Alright, so I'm going to grab my moving platform, drag and drop this script onto here. You can see we got a couple of values here. The first one we're going to want to take is the start point. Next we're going to want to take the end point and drag that in. And let's hit play. And we can see that this guy is moving back and forth and alternating. It's zooming, it's also lower. It looks like my start and end points were in weird areas, but I'm going to hit escape real quick and just go a couple of values here. If we increase the distance, it's going to slow down the speed. If we change the speed, it actually changes its position in space. So I'm going to leave this set to 1. And like I said, the higher the value, the slower the platform. The lower the value for distance, the faster. So if I get this closer to 1 here, you see that we're really moving now. Alright, the other thing that's cool about this is if I take these points, right, and move them, you'll see that the platform will actually move in real time to the positions that it's lerping to. So you could make it a vertical platform, or you can make it a horizontal platform, or you could even make it move diagonally. So that's pretty neat that once you build this thing out, it kind of gets built in real time. But what we actually need to do before that is to make sure that the start and end points line up where they're supposed to. They're -9. So I gotta set this to 0 on the Y. And I'm also gonna set the start point to 0 in the Y. And let's look at this from above to make sure that these points line up where they're supposed to. So I'm gonna select both of them, and I'm gonna move them here. And it looks like my endpoint is really far off here. Show off perspective. And I'll move both of these guys over a bit. And then the start point, let's move that so it's right where we want the platform to start here. Alright, so if I hit play, see that's moving back and forth now. Very cool. Alright, I'm just going to slow it down, so I'll select the script again, and I'm just going to increase the distance to 3 to slow this thing down. And then from here, what we're going to want to do is set this up so that our player can actually jump on it. So at the moment, if I hit play mode here and let the platform kind of do its thing and jump onto it, I don't move with it. The platform continues to move and I move off of it. So what we need to do is take that trigger that we set up on that platform. So let me tumble this back to 3D here. Take that trigger and make it so that when the character controller jumps into it, it parents it to the platform and it moves with it. So let's do that. So I'm going to bring up the script, and we're going to need a couple of on-trigger functions. So I'm just going to type in on-trigger. We're going to need on-trigger enter. And we're also going to need on-trigger exit so that we can unparent them when they jump off the platform. And I'm just going to change the parameter for collider, which is other to call. It's just going to make it a little bit easier for me to keep track of. Alright, so inside of the on-trigger enter function, what we're going to want to do is detect the player. So I'm going to actually do this. I'm going to do a public game object in our variables here, and we'll call this player. And in the start function, we'll do a player is equal to game object dot find find objects with find object with tag. Let's do that. And we'll look for player because he's already tagged as the player. Make sure you spell that correctly because capitalization matters there. Alright, so we're going to look for the player. And once they're set, we will then say if call dot game object dot tag is equal to player. And we could detect this a number of different ways, right? Through some of the stuff that we've seen so far in this course. We're gonna say player. Oh, actually, I'm sorry. Call dot transform dot parent is going to be equal to transform, and that transform is the transform of the platform. If I copy this if statement, I'm going to paste it in the exit, and here I'm just going to set this to null. So what it'll do is it'll unparent the player from the platform. So I believe that should do it. If I save this and I hit the play button, just want to check to see if my script grabbed the player. It did not. It should have. Is he tagged as player? Let's see. Oh, he's untagged. So let's tag him as player. And hit play again. And if I check out the platform, we should see player CC is in there. And I'll just go back into my scene here and jump onto the moving platform. Whoop. And you can see now I move with the platform. Pretty cool, right? What a ride. Alright, and then I can jump onto the plane on the other side. Now, just a quick reminder, right? If for some reason you're falling off of the platform, make sure you check your code and check the update function, right? If this is set to update, this will not work. So if you just leave it as the default update, and I just want to show you this as an example, because this is being updated off of the frame rate, it's not going to move the character controller component with the platform. So we'll take a look here. And we'll jump over. And we'll see I land on it. And then, oh, I fell off. Alright, so it's unable to maintain the movement with the transform of the lerp using just the simple update function. You have to use the fixed update function, which is frame rate independent. It does it based off of the physics update. Why this makes a difference, I'm not sure, since I'm not moving anything specifically with physics here, but I'm guessing it has something to do with the character controller. So you just gotta make sure it's set to fixed update. Alright, so that's it. So that's how to create a basic moving platform. I'm gonna save this, jump back, test it, make sure it's still working properly. And jump onto the platform. And you can see I'm on the platform now. I'm going to hit escape here, and I'm just going to grab the endpoint and show you how like this can just update in real time. So if I move it upward, see how we're moving diagonally now. Right. If I move it back, we're moving up and down vertically now. So pretty neat. Like we can do all sorts of cool stuff with this platform system here. Alright, so I will see you in the next video.